3.9 to 3.10 dividing fractions. I can divide fractions.
Bella, are you capable of dividing fractions right now?
Yes.
Bella, question. When dividing fractions, do we really ever divide?
No.
No. So when we divide fractions, we truly are never really ever dividing. And then Bella, just for kicks and giggles, what is that really, really important saying that we have?
When dividing fractions, my, flip the second and multiply.
Love it, love it. We'll get to that in a second. You guys, inverse and reciprocal, do they mean the same thing?
Yeah.
What do they mean? What does inverse and reciprocal mean, Mary?
Opposite.
Opposite. So an inverse operation would be an opposite operation, addition and subtraction are opposite operations. And reciprocal, when taking a fraction and finding its reciprocal, you take the fraction, like 2/3, and you flip it upside down and you get 3/2. So the numerator becomes the denominator, and the denominator becomes the numerator. Remember me. When dividing fractions, my, flip the second and multiply. On the count of 3, let's say it together. 1, 2, 3.
Dividing fractions, my, flip the second and multiply.
So our example is 2/3 divided by 1/2. By the time you are done flipping the second fraction and multiplying, you're no longer even dealing with division. There's not even a division sign in sight. Should you write your rewritten problem next to or below the original?
Below.
It should actually go down here, right?
Yeah.
Okay, so you'll see that when we get to our practice. So as Bella said, technically we never truly divide when dividing fractions. Number 5, 3/4 and 2/3. My oh my.
Flip the second and multiply.
Okay, can you cross reduce? So after you have flipped the second and multiply, this is what you end up with. Can you cross reduce?
No.
Well, you can cross reduce, but in this case there's nothing to cross reduce, right?
Yeah.
So you simply multiply. We got an improper. What do you change impropers to?
Mixed
Mixed numbers, and that should be boxed, right?
Yeah.
Okay. Really helpful on a problem like this. 6 divided by 1/2. Instead of viewing 6 as 6, we should view 6 as what? It's a lot easier, Molly, to view 6 as what? 6 over 1, right? Still the same thing, though. But then you at least have a numerator and a denominator instead of just a numerator. Okay? Okay, so we're going to skip on down. Number 7. Looks like some cross-reducing took place in number 7. Number 8, we had a mixed number, Ahmed. When you have a mixed number, when you're adding, subtracting, multiplying, or dividing fractions, what do you always need to do? Turn it to an improper. No matter what, right, Ahmed?
Yeah.
You guys, that is something that will never change, ever. That is the rule that you are going to live by forever, even when you leave this class, because it's going to make you more accurate in solving your problems. Okay, so number 8, you can take a look at yourself. Number 9. This is your word problem. The big thing, I'm not going to go through the entire word problem. The big thing is after you solve this, make sure your answer makes sense. Does it make sense that 6 snakes of Allison size would fit inside of a giant snake of Mary size? And the answer is yes. So if you actually rerun the video right now and reread the problem, you'd be like, oh yeah, I should make sure that my answer makes sense because it seems like 2 1/4 would go into 13 1/2 around 6 times. And we actually did the math to figure out that it's exactly 6 times.
Yes.
Okay, so the cheat sheet idea here was, you got a brilliance point for this. It's not coming. There we go. There we go. When doing any type of problem, check to be sure your answer makes sense. Anything to add?